Hi everyone, I'm Mr. Pauller, and in this video I'd like to show you how to create a Google Sheet to perform chi-square analysis to evaluate data from a genetic cross. Whether you are an AP Biology teacher or student, you will need to perform a lot of chi-square analysis calculations. I created a Google Sheet to speed up my calculations for grading purposes, but it could also be helpful to AP Biology students as a way of checking their calculations. Let's go ahead and get started. Here's how I created the Google Sheet. In the top row, I added a place to enter the expected phenotypic ratios for the genetic cross. I'll fill with the 9:3:3:1 ratio we expect for a dihybrid cross. In cell G1, I used sum B1 through E1. We will need this later in the sheet to calculate expected values. In the cell B9, I used sum B4 through B7, which finds the total number of observations in the data set. In cell B11, I used count B4 through B7 to find the total number of possible outcomes of the genetic cross. And in cell B12, I used count B4 through B7 minus 1 to find the degrees of freedom, which is used to determine the critical value for your data set. In cell C4, I used sum B4 through B7 times B1 divided by G1. This calculates the expected number for the first possible phenotype. In cell C5, I used sum B4 through B7 times C1 divided by G1 to calculate the expected number for the second possible phenotype. In cell C6, I used sum B4 through B7 times D1 divided by G1 to calculate the expected number for the third possible phenotype. And then in cell C7, I used sum B4 through B7 times E1 divided by G1. This calculates the expected number for the fourth possible phenotype. Cells D4 through D7 are used to find the difference between the observed values and the expected values. Cell D4 equals B4 minus C4. For cell D5, B5 minus C5. For cell D6, B6 minus C6. And for cell D7, B7 minus C7. Cells E4 through E7 are used to find the square of the difference between the observed and the expected values. Cell E4 equals B4 minus C4 squared. To do the square, we have to use the caret symbol followed by the 2. Cell E5 equals B5 minus C5 caret 2. Cell E6, we use B6 minus C6 caret 2. And for cell E7, we use B7 minus C7 caret 2. Be sure to leave the parentheses in. We want the subtraction step to happen before we square the difference. Cells F4 through F7 find the result of dividing the squared difference between observed and expected and divides by the expected value. For cell F4, use B4 minus C4 caret 2 divide by C4. For cell F5, B5 minus C5 in parentheses, caret 2, close parentheses, divide by C5. For cell F6, B6 minus C6, caret 2, divide by C6. For cell F7, B7 minus C7, caret 2, divide by C7. The final step is to find the chi-square by totaling the values found in F4 through F7. So in cell F12, I used sum F4 through F7 to complete this part of the calculation. Now that the sheet is ready, let's use it to analyze data from a dihybrid cross of genetic corn. The cross has an expected ratio of 9:3:3:1 for purple smooth, purple wrinkled, yellow smooth, and yellow wrinkled. I'll enter 9:3:3:1 in cells B1 through E1, and then the observed numbers for each type of kernel in B4 through B7. Those numbers were 99, 35, 38, 9. After I type these in, you can see that the sheet will automatically calculate the chi-square, which equals 1.07. This result is lower than the critical value of 7.81 for a dataset with 3 degrees of freedom. The calculation result means that we will accept the null hypothesis that the corn is a result of a dihybrid cross, and that any variation of the data from the expected 9:3:1 ratio is due to random chance. This type of sheet can also be used to evaluate other data sets. Once you know how the sheet is set up, it can be easily modified to evaluate data sets for genetic test crosses and survival rates of different phenotypes in a given environment. Thanks for watching. I hope you found this video helpful. You can leave me a note or a question in the comments below. And if you're looking for more content like this, please use the links in the video description. Until next time, stay curious.